Good morning, Year 7, and welcome to your Lesson 3, which is Refraction. You have had a look at light and the eye, you've had a look at reflection, and now we're having a look at a topic which sounds really similar to reflection, but it is refraction. So, can you please write down the title and underline it? Lesson 3, Refraction. Then, I'd like you to write down the keywords for today. We've got a couple. They are refraction, normal, ray, density, medium, incident ray and refracted ray. Then you don't have to write them down, but I'd just like you to have a look at the learning objectives for today. We are going to describe what happens to light when it passes through materials of different densities. We're going to draw ray diagrams to show refraction of light, and we're going to explain why light changes direction in different materials based on density. So pause the video if you need to get your title and keywords sorted, and then press play when you're ready to move on. Hello Year 7 and welcome to your third lesson on light. This lesson is on refraction. Now to start you off, I would like you to have a look at what I have got here. I have got, and you can try this at home, just a normal glass of water with a pencil in it, but you will notice something about this, which is if you look at the pencil, it looks as though it is bending when it goes in the water. Now I'm going to take the pencil out. It is a totally normal pencil. You can do this at home, and yet when you put it in the glass of water, it looks like it is bent or almost like broken there in the middle. Your first job of today, please, is to write down in your book or on your paper just a suggestion as to why you think that is happening. So have a little think, just a suggestion. It can be a sentence or it can be a couple of keywords, but I'd like you to have a go at that, please. So as you saw in the video, and you can see in the picture here, if you put an object into water in this way, you can see that it appears like it is bent. Can you just write down your own suggestion? It is a suggestion, there's no right or wrong. We haven't done this topic before, or you may have looked at it briefly in class. So write down your suggestion in your book. Don't be shy, whatever you think. And at the end of the lesson, I'd like you to refer back to your suggestion and see if you still agree. The first thing that we're going to explain when we think about refraction is actually we're going to ignore light for a second and think about a car. So you can see this lovely orange car going on a trip, and it is going on a nice smooth road, but then it hits mud. And when it hits mud, because the car is driving in at an angle, one tyre is going to hit the mud sooner than the other tyres, and that tyre that hits that mud is going to slow down. And because one of the tyres is going to slow down, it's going to make the car bend and turn. And that's why when you can see the car driving on the mud, the car is driving at a different angle. But then the mud's going to run out and it's going to get back to the road. But because it's, again, coming to the road at an angle, one of the tyres is going to hit the road sooner. And that tyre that hits the road is going to start moving faster. And because of that, the car is going to turn again and bend and go at a different angle. And you can see that the angle on the road at first and the angle on the road afterwards are both the same, but because it's slowed down in the mud, the angle has changed. You can see a little dotted line there, that's the normal line, and you may notice that in the mud, the angle of the car is closer to the normal, and that's going to come in useful later on. So let's use that knowledge now and apply it to light instead of a car. In this picture, what you can see is the yellow ray of light travelling through air, then it hits a perspex, like a plastic block, and then it goes back out into the air again. And instead of having a car, now we've got a beam of light. I'd like you to draw this out in your books and write down these phrases at the bottom as well. When you're drawing diagrams like this, you must use a pencil and a ruler. The lines must be straight. They must all be joined up, no gaps. And you must have your arrows on your rays of light to show which ways they are going. So while you're doing that, I'm going to explain that light travels in straight lines. This is what it says at the bottom. And it's traveling through air to start off with. Now, air is a gas. The particles are moving around, they are not very close to each other. So light is having an easier time moving through air. But then the light hits the perspex block. It is more dense than air. There are more particles for the light to have to go through. So that causes the light to bend because it's moving through a more dense medium, and it bends towards the normal. Once it's made its way through the perspex, it can go back out into the air, which is less dense, so it bends away from the normal. So draw that in your books with the explanation, please, and then we are going to watch a video of this in action.
Hi Year 7, I'm going to show you something else now on the topic of refraction, and for this I have got a laser box that creates a laser. We've got a perspex block and just some paper underneath. Now the first thing I'm going to do is to draw around my perspex box, because in a second I'm going to have to take it away, but I'm going to have to make note of where it was on the paper. So I'm going to draw an outline of my perspex box. And the first thing I want us to have a look at is this laser beam at the moment is travelling directly into the perspex block here. And as you can see, because it's going at such a straight line, it continues on a straight line through the block, and it continues on a straight line out of the block as well. So as you might remember from your lesson on reflection, that line is known as the normal, and the normal is at 90 degrees to the mirror or the block or whatever it is that you are looking at. So what we're going to do is we're going to mark our normal, and we do that with a dotted line. So I've done that there. But because we're now looking at refraction, not reflection, I want you to have a look at what happens when we do this. So I'm going to move my laser box now. I'm going to move it so that it goes into the block at an angle. And what I can show you is, if you imagine the light first travelling into the block, the first thing you're going to see is that not all of it travels through. Some of it actually gets reflected. But you can see that the reflected line is less intense because not all of it is being reflected. Some of it is, and some of it is travelling through the block. So making sure that I put my beam in at where the normal hits the block, we're now going to send that through, and we can see that as it goes in, something happens to it. Because it is now going from air, the light here is travelling through air, and there aren't that many particles in air, they're very spread out, it's a gas. But then it has to travel through this solid, and this solid is much more dense than air because there are lots of particles much closer together in this solid. So this light is going to have a bit of a harder time travelling through, and what that means is that it starts to bend. And you can see here that it's going in at this angle, but now it's bending, and it's changing the angle. But as it leaves the perspex block, it is leaving a more dense material, or we call it a medium, a more dense medium, for a less dense medium because it's going back out into the air. So it goes in at one angle, bends, and then comes out at the same angle that it went in at. And we can mark this on our diagram. So I'm going to do that now. I'm going to mark where it's going in. Which actually, now that I think about it, should be a straight line, but I'm going to do dotted lines to just mark where it is, and I can make it a full line in a minute. And I'm going to mark where it's coming out. And that means that once I take this block away, now you can see, that's quite cool, you can see the difference that this block makes when it's on the paper or where it's not on the paper, and see how that line changes. But now that I've marked my lines, what I can do is I can join them up here. And always remember with ray diagrams to draw your arrows to show which direction the light is going in, and they should always be joined up, no gaps. And I'm just going to move this, and I'm going to draw this one here. My dotted line isn't the neatest thing in the world, but that's okay. And if I were to carry this line on, like we just saw when the block left, it wouldn't actually be coming out the right way. it'd be up here, but it isn't because the block made the light bend, and we call that refraction. The block made the light refract and bend, so we have to get this different angle here going through the block. Now, something else that we can do is measure the angles that we get here. So, as we know, that's our normal line. And what I'm going to do is grab a protractor, measure this normal, and see if this angle is the same as this angle. Okay, so what we've got here is our normal line. Remember, that goes at 90 degrees, and our normal line here, which also goes at 90 degrees to the block. Now, if we have done this accurately, we should have this angle should be the same as this angle. So we're going to measure them and find out. Firstly, we're going to measure this angle starting on my normal at 0. I can see that this angle is around about 18, 19 degrees. And that is the angle of incidence. It is the incident ray that is going into the block. So this is the angle of incidence. Sorry that that's upside down for you guys. That is 19. And I am going to measure this one as well. And we are pretty much there. That is about 19 or 20. Let's call it 19 because the angle of refraction will always be the same as the angle of incidence. Remember, you measure between your normal and your ray, and we've measured between the normal and the ray, and we found that it is the same here and the same here. And that is refraction.
All right, now that we've had a little look at how refraction works, I'd like you to have a go at completing these sentences. You've got words in the box at the bottom. So when light enters a more dense material, it bends blank, the blank. So use the words in the box to fill out those 3 sentences. You can have a look at the diagrams to help you and see how you get on. Okay, how did you do? You should have had, when light enters a more dense material, it bends towards the normal. When leaving a more dense material, light bends away from the normal. Light travels straight in all materials. So well done if you got those. If you didn't, make some corrections. And I'd like you to write down the bit in red at the bottom where it says refraction is caused by light passing from one medium to another, e.g. from air to water, and experiencing a change in speed. We're going to put this into practice again with an exam style question. So here you can see a diagram. It says it shows a ray of light hitting the surface of a mirror. Mirrors are always shown like that with a dashed line at the back. So if you see that, that's a mirror. It's a mirror made from thick glass. The incident ray is both reflected and refracted. You can see the ray going in there, and then you've got some letters for these 4 rays, A, B, C, and D. Give the letters of the 2 reflected rays, something and something. Give the letter of 1 refracted ray, and then the incident ray is brighter than ray A. Give 1 reason for this. 3 marks. See what you can do with these questions. Answers are coming up. Okay, marking your own here, you have got that A, the 2 letters of the 2 reflected rays are A and C. Now you might have put A and D because those are both coming away from the mirror, but if we have a little look at the incident ray, you can see that A is being reflected straight off the mirror, so that's one of the reflections. But then there is part of the ray that travels through the glass. So you can see B is transmitting through the glass, it hits the back of the mirror, and then it reflects again, so that is C. The 2 reflected rays are A and C. Very well done if you got that right, because I think that's quite an easy one to get wrong. Number 2, give the letter of 1 refracted ray. Remember, a refraction is a ray of light that has changed direction. You could have either said B or D. Either one of those is correct. The reason that the incident ray is brighter than ray A is because not all of the light is reflected. Some of it's refracted, some of it's absorbed, and the glass will make a bit of the light scatter. You could have said any of those will get you the mark. So well done for having a go at that. Give yourself a mark out of 3. At the beginning of this lesson, we had a look at the pencil trick when you put the pencil in the water and it looks like it's bent. You made a suggestion as to why you think that is. Now I'd like you to revisit that suggestion and see if you can improve it now that we have learnt about refraction. If you would like, you can use this sentence here and fill in the words. So you've got words in the box, see if you can fill in the correct ones, and that will give you your explanation as to why the pencil looks bent. Compare it to your original suggestion, see how close you got. The answers are coming up next, so pause the video. And here is what it should have looked like. When a pencil is put into a beaker of water, it looks bent. This is because the light is refracted as it leaves the water. The light travels faster in air than water. Hopefully you got on well there. Give yourself a mark out of 3. Very well done. Once you have finished watching this video, you are going to now go on to Edulink because there is a worksheet there for a magic coin trick. You can try this at home. All you're going to need is a mug, a coin, and some water. So have a little go at it. You must put the coin in the mug with no water and get yourself to a place where you cannot see the coin. Then you're going to fill the mug with water and see if you can now see the coin from the same angle. It's a really good trick. You can show people in your house, a little bit of magic there, and have a go at the worksheet that goes with it. And that, Year 7, is the end of our lesson today on refraction. Very well done for logging on from home and doing your work. Really, really impressive. I'd like you to make a little note in your book at the bottom of this lesson. How do you feel about your progress today? You can do a little thumbs up, middle or down, or you can give like a mark out of 10. Just make a little note as to how you feel you got on. Now remember to go onto Edulink, find that worksheet, have a little go at home with a coin and a mug, see if you can do the trick, and complete the worksheet. Very well done, everybody. Good job.